Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University, and you can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU-actuary. Here's the problem for today for exam P. You are given that the joint density of random variables x and y is f sub xy of xy equal to 4x over y for x between 0 and 1 and y between 1 and a square root of e, and f sub xy of x and y is equal to 0 otherwise. Find the variance of y given that x is equal to 1/4. And here's the solution. So the joint density is positive on the rectangular region with sides parallel to the axis, and on that region the joint density is a product of a function of x and a function of y, where there are certain constants multiplied by x and by 1 over y, and therefore x and y are independent, and that means the variance of y given that x is equal to 1/4 is equal to the variance of y. And then we can find the first moment of y, or equivalently the second moment of y, as a double integral of y times f sub xy of xy dy dx, because that's just a two-dimensional calculation of expected value of a function of two random variables x and y. So we take a double integral of y times the joint density, either way, either with respect to y first and then x, or with respect to x first and then y. Of course, we get the same answer because of the Fubini theorem. And we can do this for y and for y squared. So all this is really just hand-waving about something that you should know that's clearly explained in the section 3 of my study manual. This is something that is expected of you to know, straightforward. So we just find the variance of y given that x is equal to 1/4 as the variance of y as e of y squared minus the mean of y squared. And e of y squared is the integral from 1 to square root of e, that's with respect to y, of the integral with respect to 0 to 1 with respect to x of y squared times the joint density 4x over y. And the e of y is the integral from 1 to square root of e of the integral from 0 to 1 of y times the joint density of x and y, and then that mean is squared. So this is the integral from 1 to square root of e of the integral from 0 to 1 of 4xy dx dy minus the integral from 1 to square root of e of the integral from 0 to 1 of 4x dx dy, and the whole thing squared. Now, in both cases, you can immediately see that you can just write these integrals as the product of two integrals, one with respect to x, the other one with respect to y. So that's the integral from 0 to 1 of 2x dx times the integral from 1 to square root of e 2y dy. That's a direct consequence of the Fubini theorem. And the second one is the integral from 0 to 1, 4x dx times the integral from 1 to square root of e of dy. And then we square that mean. And the calculation is straightforward. The integral of 2x is x squared, evaluated from 0 to 1. The integral of 2y is y squared, evaluated from 1 to square root of e, minus 2x squared, which is the integral of 4x, evaluated from 0 to 1, minus the integral of a constant is just square root of e minus 1, and the whole thing in the second case is squared because we're taking the square of the mean. So this is e minus 1 minus 2 times square root of e minus 1, the whole thing squared. That's approximately 0.0349, answer D. Or, if you want to do it the traditional way, f sub y of y, given that x is equal to 1/4, is equal to f sub xy of 1/4 y over f sub x of 1/4. That's 1 over y over the integral from 1 to square root of e of 1 over y dy. So the top is 1 over y, and the bottom is natural logarithm of y evaluated from 1 to square root of e. And that's 1 over y over 1/2, so it's 2 over y for y between 1 and square root of e. And that, therefore, the expected value of y, given that x is equal to 1/4, is the integral from 0 to square root of e of y times 2 over y dy. And that's just 2 times square root of e minus 1. And the second moment is the integral from 1 to square root of e of y squared times 2 over y dy. And that's the integral of 2y, so it's y squared, evaluated from y equal 1 to y equal to square root of e, so this is e minus 1. And we have exactly the same answer as before, e minus 1 minus 2 times the square root of e minus 1 and the whole thing squared. That's approximately 0.0349. Answer D again. The purpose of this exercise is, of course, to get you to do it the first way, because it's one calculation and very direct and very straightforward. And in the entire explanation or hand-waving at the beginning was completely unnecessary, because you should know that stuff when you take the test. It's again in section 3 of my Exam P study manual, and it's laid out there, and you're expected to know this for the test. One of the most important things for all actuarial exams is the expectation from the examiners that you know every possible approach to finding the expected value of variance or moments of probability distributions. Not one, not the only one that whoever was teaching you probability showed you, but every single one, including, of course, the Darth Vader rule. In this case, because we're working with the second moment, you can't use the Darth Vader rule. You could use the Darth Vader rule for the first moment, but not for the second moment. Although, of course, they asked the question about the applicability of the second moment of the Darth Vader rule to the second moment on the last LTAM exam, because the Darth Vader rule is always in the background on actuarial exams. So, it's important that you know that you can calculate the expected value or the moments of a random variable from the joint probability distribution by treating that y or y squared as a function of x and y, and just doing a straightforward double integral calculation in one step. Because y is a function of x and y. And if you write the function h of xy as I write in my study manual, then h of xy is equal to y. And for the second calculation, h of xy is equal to y squared. And you should have learned this in your probability class. And of course, you learned it in section 3 of my study manual. Please remember, this is copyrighted material. The problem was created by me and the solution is mine. Good luck in your studies and good luck on the test.